Hey guys, this is Luke with the lab. Here's for your update. So first off, sorry about my lapse in updates. It's been a lot. Long story short, beginning of the school year, I have two little kids, 7 and 9. They started their school year, so it's been a lot of hubbub with that. So I got a little distracted. As of the last couple days, a couple people posted and emailed me asking for updates. Sorry, I got sick. You can't tell from my voice there, so I had to take a little bit off just to recovering and get back to it. So I appreciate your patience and looking forward to giving more repeated updates again. Again, big apologies. So what has happened? So a lot has happened. So first off, I have some exciting things to show. First off, that is copper. Let's go. So copper is loaded. We have done a complete swap of the entire system. So down here we can actually see all the fun things that we swapped over. So these are the channels that the 12-foot bars all ride and spin in up to like 8,000 RPM. And yeah, so we had to swap all those out. These are much bigger than the copper that we're using in here. So you got to swap it all out, including a pusher and a catcher system and then a telescoping tube. So we swapped all of this out, including the collets and everything else. This tube here, we added a tube reducer inside the spindle itself, the spindle collet, the guide bushing, the spot where the actual material comes in. Here, I'll just kind of turn this off and kind of point it out a little bit. So the actual guide bushing that goes in here as well, and then this sub-spindle collet. So those are all swapped out. Next, in order to cut copper, we're going to swap over some of these inserts. So I have another really cool thing. So I've been trying out a couple different recipes, a couple different things here and there, and I have some pretty cool tooling that we're really excited to use. So we have diamond tipped tooling. So if you take a look at here, you can actually see that is a diamond brazed or soldered or some adhesive method onto the tungsten carbide. And the geometry of this one is actually a chip breaker. So as you go past the tool, it'll actually break the string of copper and aluminum, so technically these are good for both of them, into little teeny tiny chips instead of big strings, which are very annoying for challenge. So this is some of our other tooling here. So this one's actually been previously used with aluminum. So this one is just regular geometry. You can see from the edge of it right there, but this one just uses normal straight stuff. Otherwise, we have a lot of our tooling out here for the heat sink and for the copper. So we have our end mills, we have our main filament drill, we have our pilot drill, we have some reamers here, we have our flat bottom drills for making the threaded surface, or making the threaded counter bore, essentially. We have some of our taps. So these right here are the holes for holding on the wings, and then here are the taps for the nozzle, the fin nozzle, and for the heat brake. So that's very exciting, very exciting for us. These are also roll form taps instead of cutting taps. So this is important. Well, it's very likely not actually important, but it's a quality increase because these, instead of cutting material and interrupting the grain boundaries, this actually rolls and forms and reshapes the grain boundaries, making a much stronger uniform thread in the material. So we're going to give this a shot. The manufacturer of the copper did not recommend this for it, but apparently you can do it. So we're going to find out. If they snap, they snap, and we'll go with standard cut threads, which I have spares in here, and we'll just cut the threads instead. So, you know, no great loss. Otherwise, we have some of our other small drills, and yeah, that's what we really need. So we're going to use all the really cool features of this machine to make sure that, here's an older prototype block, to make sure all our flat sides are nice and flat. We're going to use both sides of our gang system to make these as efficiently as possible. That's very, very, very exciting for us here. So otherwise, here's something pretty cool. So this is an off-center but yet centered collet. So what this does is this will grab our heatsink and then clamp it in place, and it has that hole. Well, if I rotate it the other way, so here, put it in like this. I'm doing this as one shot, so you're just gonna have to deal with it. So it has the hole in the exact center line of the collet. So it'll clamp around it and allow us to finish the part all in a single shot. And so we finally got these things in. It took a while, some miscommunication between myself and the vendor, but they're here, they're near, and that'll work great. And the other cool thing is that we actually have the same for the actual heat block as well. So we have this here that will, again, this is an older revision, so it's not the same size, but that will go and clamp around the square portion here and allow us to work on the opposite side to do our threading and our drilling and all those operations on the other side. So that's super cool, super grateful for those things to come in. What else do we have here? Man, there's just been so many cool things. We have some of our metrology equipment. Oh, I know what we can do. We can go look at our cool new measuring system. That's pretty cool. So, all right. So it turns out I am doing this in 2 takes. So I guess this is it. So we have our CNC automatic vision system. So this is something that we got, and the reason for it is really important. So this is a camera unit here, and this is actually a Renishaw probe on the side of it. This platform is granite and motorized, so this is actually constructed with granite on the side for stability, a granite window, and then here's glass so it can shine light all the way through. So this is capable of inspecting our parts down to 3 micron plus length divided by 200. So if we had a 200 millimeter long item, it would be able to inspect it down to a tolerance of 3 plus 200 divided by 200, so 1. So 4 micron. And it would be able to do that forever. So I am super excited because we are going to be producing high quality nozzles, high quality hot ends, high quality heat sinks, and everything that we can will be inspected on this machine at a frequency that makes sense for the part. So if we have a part that's, and I say frequency, there's whole studies and math on what should be done for what quality of part. So our nozzles are going to be inspected quite frequently because they need to be concentric and they need to be of the highest quality. And so I'm super excited to share those results once we get this thing running. In addition, it has a Renishaw probe that will be actually able to use and measure flatness and correlate our vision system with our actual measurements. So it'll be able to touch points in a circle and then measure the points in the circle to make sure that our vision system is right. Basically, it's a sanity check for me, the operator, as much as it is for anything else. But I've been waiting for this particular system for a very long time. Like, this has been basically when we launched the Kickstarter. Like, I've been waiting for this system already, and it's super exciting to finally have it here. So this will be moved over to the other shop eventually, but not right now, just because they're not done. My apologies for my voice. They're not done moving out yet, as is the tradition. And so we're really excited to show you what we can do and how we're making parts. So I appreciate your patience. I'm sorry I don't have like shiny parts in my hands or anything like that. Hold on, maybe I do. We're gonna make another cut. All right, so hopefully the last cut here. So these are the first parts that we actually did make on the Swiss for our existing product line, the Chew, which is what we originally started our whole purchase contract and all this kind of stuff here. So you can see that nice shiny surface produced by the diamonds, the diamond cutting tool there. And then everything on here between the 300 part run that we did was repeatable within 5 micron. So when I take a micrometer and I measure the outside of it, it doesn't budge. And I understand that there could be measurement inaccuracies, so fine, 10 micron, right? But as you can see, like it is a big step up for us, and we were able to produce cool parts. So this is the cool shiny part I get to show you guys, because this is actually the original reason we went down this journey of becoming our own machinists, was to produce parts for the tube hot end and for the subsequent and shortly upcoming next model of the tube. It's really exciting to finally be able to produce our own parts, and us getting that machine, the Swiss lathe. Us getting the Swiss lathe is what allowed us to even consider making the Pika in the first place. So the update essentially is like the whole product can exist because I'm able to control my own destiny, and you've helped me make that a reality. And so you control my destiny, and you have made my existence possible. And so for those out there who are also supporting this, we also managed to one last update. Man, I just keep rambling all this time, right? One last update is that we'll have a Maker's Edition. So what does that mean? So for the people out there who are looking for the bamboo hot end for Bamboo Labs, like everything you have is currently set. Like we are all happy. We have bags and bags and bags of heaters and everything else that are meant for the bamboo, ready to go. So thermistors on thermistors. We got heaters on heaters and thermistors. So like we're good to go with that. All right, so like that's good. But what's really interesting is that the market for the bamboo hot end, since it's ubiquitous and everyone has parts for it, and it's common, is that many DIY users, which is the group of people that I started. I'm a normal person who like 3D printing, right? So those people, they adopted the hot end because it's everywhere, and so we found a place that is able to do non-positive temperature coefficient (PTC) heaters in 100-watt flavors. So we'll be able to produce a heater that doesn't drop in wattage, which is not compatible with bamboo at all. Like their software's not set up for it, their hardware's not set up for it. Don't do that. Like use their hardware as it's intended. But for the people who are doing like a Voron or a Stealth Changer, or they're upgrading their Cheaty, or they're building whatever it is you're building, you're upgrading your Ender 3, like fine. We'll be able to support the higher temperatures and higher wattages, because those platforms are safe to run 100 watts. They are safe to experience higher temperatures that because they have more open infrastructures and ecosystems, that you'll be able to do that as well. Like you'll be able to enjoy this product once we fulfill all the backers. So that's just something that we kind of finalized in the last month or so, that we can get these heaters made and that they're good quality. And so I'm really excited to announce that, even though it may not matter to 90% of the people who watch this video and read the update. I just want to provide that even though there's been some more delays than I thought would be possible at this point. I'm a very seasoned project manager. Take your timeline, triple it, and then add a week, right? We're still looking good for delivery by end of October. I have all faith. We are full steam ahead. I have become a fast programmer and have really I'm having a really good time, other than occasionally being human and catching illness and having a family still and that kind of stuff. But I just wanted to again say my apologies for not updating at my normal 2-week cadence, and thank you for your patience and your trust. And I am very, very excited for what we're creating here and what we'll be able to deliver to you soon. So the last little bit is I can keep just extending my rants here. It's just been a long time since I updated you guys. the last thing that we have is that we'll be at 3D Printopia next weekend, the 27th, 28th in Bel Air, Maryland, I think. We're really looking forward to that. We'll have our new next generation hot end in the tube lineup. They're showing off for the first time, as well as the Pika. We'll have both printing and happy, and we're really excited about that portion too, and excited to meet many of you out there who have known me before the Kickstarter, and for the people who met me because of the Kickstarter, or followed me, or watching this video because you're like, where the hell's my damn hot end? We'll be there. You can ask us then, and I'll be more than happy to yap at you as long as my voice lasts those days for that. So thank you very much for staying with us on this journey, and I'll have an update for you guys in the next 2 weeks again, and see you, all of you, at whoever wants to visit at 3D Printopia. We'll be there, and looking forward to it. So thank you. Have a good one. Have a blessed week. Thank you. Bye-bye.